Okay, so welcome back, and today we're going to start talking about adding and subtracting vectors now. Okay, so again, this is going to be a visual exercise. It's going to be important that you pay attention and look at how I do this, because this is the way to help you when you're tackling these problems about adding and subtracting vectors. You'll be able to visualize it and then be able to make sure you get the correct answer. So I drew the same vector, at least hopefully the same vector here. And I'm going to show you the addition. So let's call this vector u and this vector v, u and v. So when you add vectors, think about adding arrows. And so when you add vectors, in the case of physics, you could have force vectors, right? So we could have a force on an object, but that force can be split up into two component forces or component vectors. And let's say you have one vector going this way, one vector going that way, but the sum of the forces, you want to know, hey, what's the result of both of those forces on an object? So you would add those two vector forces together. So how do you add vectors? Well, what you do is you slide the vector from tail to nose, tail to nose. So tail to nose of one vector and tail to nose of the second vector. So what you would do is you would slide this vector up here, for example, if you wanted to do let's say u plus v, right? So if you wanted to do u plus v, it would be you would slide this vector up to this vector here, to the tail, and draw the line of the vector. Okay? And so this would represent adding the two vectors, u plus v, right? And so the resultant vector would be the force of the summation of these two forces. So it would be from the tail of the first vector to the head of the last vector, or the second vector in this case. And so this is what we call the resultant vector. Okay? And that's the sum of the two vectors, u plus v. Okay? And so this is the resultant vector that tells you the direction and the angle or the magnitude of the forces combined on an object, let's say. Okay? So this would be represent adding the two vectors. Now what about subtracting? Now subtracting is similar to adding, because you could call it adding a negative vector, right? So you could say, if I wanted u minus v, that would be the same as saying, that would be the same as saying u plus negative v. Which means what we would do is we would have the opposite, right? So instead of v, so instead of here, this would be the same as this, so we would take the negative of the vector. So the vector would have to be going in the opposite direction, so it would be going this way. And then we would slide this up to here. Like so. So in subtracting vectors, we could look at it as adding the opposite of a vector. And so we would have the vector going the other direction. And so this would be negative v, right? So this would be negative v. And so then the resultant vector, again, would go from the tail of the first vector to the head of the last vector. And so it would look like this. Like that. And so this would be the resultant vector. So this would be subtraction, if you will, and this would be addition. Okay, and so that is what we're going to do in a lot of the examples. Okay, now this is graphically. Now, how does that look when we're doing it? Well, algebraically, or when we're actually calculating what the resultant vector looks like. Because let's say we have two vectors that are in position, right? Two position vectors, right? And we want to add those two position vectors. Well, that's going to give us a resultant vector that is also in a position form, and so we want to be able to see how we handle that. So that would be another instance, but we'll see if we get there. So anyway, this is what the introduction, and we'll do a couple of examples of how we find the resultant vector and how we add and subtract vectors, and we'll go from there. Have a great day.